Hi, my name is Kashish and I'm a chem major at UCSD.
Good joke. My name's Greg and we're both AP chemistry students at Del Norte High School.
Today we're going to be reviewing a question on thermochemistry that can be found on page 6, number 6 of the thermochemistry notes by the National Math and Science Initiative. Here's the question. It has been suggested that hydrogen gas obtained by the decomposition of water might be a substitute for natural gas, principally methane. To compare the energies of combustion of these fuels, the following experiment was carried out using a bomb calorimeter with a heat energy of 11.3 kilojoules per degree Celsius. When a 1.5 gram sample of methane gas was burned with excess oxygen in the calorimeter, the temperature increased by 7.3 degrees Celsius. When a 1.15 gram sample of hydrogen gas was burned with excess oxygen, the temperature increased was 14.3 degrees Celsius. Calculate the energy of combustion for hydrogen and methane.
So this problem is asking for the calculation of the energy of combustion per gram for hydrogen and methane. In order to do this, we need to understand the following concepts: that in a bomb calorimeter, Q is equal to C delta T, and that the energy combustion per gram is going to be equal to the Q calculated from Q is equal to C delta T divided by the mass. In this case, Q is equal to the energy, C is equal to the specific heat, T is equal to the temperature, and M is equal to the mass.
There is some important vocabulary we need to know to solve this question. The energy of combustion is how much energy it takes to burn CH4 in a bomb calorimeter and H2 in a bomb calorimeter. A bomb calorimeter is a device for determining heats of combustion by igniting a sample of high-pressure substance in a sealed vessel to measure temperature.
Alright, so we're going to want to find out the energy of combustion for H2 and C and CH4. So first we're going to start off for H2, and we're going to try to find the energy of combustion of 1.15 grams. So now Q is equal to C delta T, so that's going to go to Q is equal to 11.3 times 14.3, because that was the temperature change and the delta and the C. So now we're going to plug this into our handy dandy calculator, CX Inspired CAS. 11.3 times 14.3 gets 161.59. But wait, there's 3 6 figs. So we're going to have to round up to 162 kilojoules. Now we're trying to find the Q over M. So, because we're trying to find the energy released in 1 gram. So the energy released in 1 gram. So this is the total energy for 1.15 grams. So we're going to take 162 divided by 1.15. And again, we plug this into our handy dandy CAS. We get 140.87, but wait, again, it's 3 sig figs, so we get 141 kilojoules, and that's the energy of combustion for H2. But they didn't ask for just H2, they also asked for CH4. So now we do the same exact process, except just different numbers. The energy of combustion of, now it's 1.5 grams of CH4, so Q, that's about Q. Q is equal to C delta T. So Q is equal to 11.3 because it's the same. It's the same heat capacity. Then you times the temperature change of 7.3 degrees Celsius. So get Q again into the CAS. 11.3 times 7.3. So 82.49. But hold on. There's only 2 sig figs this time, so it's 82 kilojoules. So now, same thing. This was the energy for 1.15 grams, so it's going to be 82 divided by 1.5 grams. That's going to be the energy of combustion for 1 gram. So it's 82 divided by 1.5. You get 54.667, but you want 2 sig figs again, so round up to 55 kilojoules. And that is the answer and how you solve this problem for this. So you get the energy of combustion is 141 kilojoules for the H2 and 55 kilojoules for the CH4.
Today we learned how to determine the energies of combustion per gram of different substances in a bomb calorimeter given only the mass, specific heat, and change in temperature. We utilized our formulas by plugging in this information to give us the energy of combustion per gram for hydrogen and methane. Once again, my name is Kashish.
I'm Greg, and thank you for watching our video on thermochemistry and bomb calorimeters.